Good day, ladies and gentlemen, and welcome to your How to Make a Safer and Healthier Environment Through Human-Centric Lighting conference call hosted by Energy Focus. All lines have been placed on a listen-only mode, and as a reminder, today's call is being recorded. At this time, it is my pleasure to turn the floor over to your host, Michael Decker. Sir, the floor is yours.
Thank you so much. Again, my name is Michael Decker. I'm serving currently as the Vice President of Marketing at Energy Focus, and I'm very pleased to be your host today. I just want to mention that you can ask questions at any time during this presentation, so feel free to go ahead and type those in on the panel, and we will get to those at our Q&A session at the end of the 45-minute presentation. I am very happy to introduce James Tu, who is our Chairman and CEO of Energy Focus. James has been the CEO since April 2019 and was in the same position from 2013 to 2017. Under James's leadership, Energy Focus developed and launched a series of breakthrough and patented lighting products, such as the industry's first flicker-free LED lamps, integrated emergency backup LED tubes that we call RedCap, also retrofit-focused lighting control platform and Focus, and our new UV-C Disinfection Solutions that we just unveiled today. James has been an active advocate and investor in sustainability technologies since 2011. Before then, he was the Director of Investment Management at Gerstein Fisher, managing $1.5 billion in assets, and an analyst at Dolphin Asset Management. James graduated from Baruch College with an MBA degree and Tsinghua University in Taiwan with an electrical engineering degree. I'm also really excited to introduce Chris Johnston, who is our Director of Total Sustainability. Chris Johnston completed his degree with the University of St. Andrews in the UK and received his degree in their Sustainable Development Program. Chris also wrote and produced an award-winning environmental documentary, and he received the EPA's Presidential Environmental Youth Award in 2012. With the Energy Focus team, Chris is working to reduce the life cycle impacts of lighting projects while maximizing the health benefits. He is based in the New York City metro market. And now I'm pleased to turn this presentation over.
Thank you, Michael, and good afternoon, everyone. Thank you for your time and interest in listening to this webinar that we're very excited about. As many of you probably have heard about Energy Focus, we have been a leading LED lighting innovator since 2007, and actually we started into LED lighting development in 2003 with the DARPA, which is a Defense Advanced Research contract to develop the next generation lighting for the U.S. Navy ships. And today our LED lamps are on every U.S. Navy surface ship, and many other mission-critical facilities such as National Institute of Health, Cleveland Clinic, Mayo Clinic, and large universities and hundreds of school districts across the country. And I think the unique advantage of our Energy Focus is that it has is that the products that we develop are not only high in quality and very proven in these mission-critical facilities, but also that we continue to innovate, leading the industry in innovation based on the triple bottom line principle, which aims to improve human, environmental, and financial bottom lines. And because of that, we are able to develop products that help facilities accomplish these goals. And that's also how it has driven us to develop Human-Centric Lighting, which we are a very big advocate on as technologies are making them possible. And our goal is to make Human-Centric Lighting impactful, reliable, and affordable. So if you look at the past 100 years of development, you can see that things from 1880s from Thomas Edison, where incandescent lighting was developed, the lighting has stayed in the same situation in terms of giving out light for about 100 years, until about early 2000s when LED becomes more commercialized. And really in the past 10 years has LED lighting been commercialized. And through the past 120, 30 years since lighting was developed, it has basically focused on just two things. One is giving out light, and when LED came along, it started to focus on giving out more efficient light. What we are seeing now and what we are developing into, we believe very excitingly, is the age of human-centric lighting. And that is going to, because of the technology developments that can be incorporated into lighting, now we can start seeing huge impact on humans directly, right? Not just the giving out light, not just about more efficient light, but also starting to enhance the biological health and well-being of people through advanced capabilities such as flicker-free, dimmable, color tunable, and also what we call circadian lighting, as well as the UV technologies that where we just launched our products today. We are leading the industry towards that whole age of human-centric lighting in the next few years, where the impacts will be much greater, I think, compared with what lighting has done so far, because it has moved from purely lighting to lighting technologies. And next, Chris will talk a little about the background of human-centric lighting.
Thanks for that, James. Great introduction to human-centric lighting. So when we're talking about human-centric lighting, we're really talking about the emotional, biological, and physiological impacts of lighting. So this is a nice little chart that we developed to show the visual and non-visual benefits of lighting that can be gained through lighting. When we think of lighting, we typically just think of being able to perform tasks. So proper light levels, proper color of lights, like the CRI. But lighting can deliver far more than that. So when we're talking about circadian lighting, we're talking about lighting that can affect your sleep-wake cycle. So your circadian rhythm is a roughly 24-hour biological cycle that affects everything you do. Every cell in your body is affected by your circadian rhythm. Everything from your sleep-wake cycle to your body's temperature cycle, getting cooler at night and warmer during the day. Your autonomic nervous system, cortisol, melatonin, that's all influenced by your circadian rhythm. So through human-centric lighting, we're able to impact that. And new developments in UV technologies have enabled us to even more effectively disinfect both the air and surfaces around us. So now we're going to go into the eye and photoreceptors. So there's two pathways that go through your ocular system. So there are three photoreceptors in that pathway. The first are your rods, the second are your cones, and the third are your retinal ganglion cells. So you can think of your rods as sort of low light cells. They're all neurons that have proteins in them that are light sensitive to different wavelengths. So your rods are more for dim light, so light like high light levels, dark light levels, no color whatsoever. Your cones are sort of your color receptors, and that's sensitive to three different wavelengths: your short wavelength cones, your medium or middle wavelength cones, and your long wavelength cones. And then there's melanopsin, which is a light-sensitive protein in your intrinsically photosensitive retinal ganglion cells. Now, what's important about this is that this is key for determining how to entrain the circadian system to keep it more in line with a 24-hour clock. So you can't just take into account what your rods are sensitive to, or what your cones are sensitive to, or what your retinal ganglion cells are sensitive to. You have to take them all into account together. And what's kind of cool about this is we only discovered the IPRGCs in the last really 30 years. In the 1990s, we started getting into it, and then in the early 2000s, we just determined a fair bit more about it. So the different wavelengths that they're sensitive to, your cones, obviously more color sensitive, while the retinal ganglion cells are sensitive to right around 450 nanometers. So when we're talking about visual comfort, which is another aspect of human-centric lighting because of the health implications, we're talking about the electrical modulation of current to a light source. This nice little optical illusion on the left here is to help you recognize that vision requires effort. Your brain is expending energy to process that visual information from your ocular pathway, from those photoreceptors. So you can probably feel your eyes working, probably a bit uncomfortable. That's what you would experience under highly flickering lighting. But there's different levels of that, and none of it is good. You really want to reduce the amount of flicker that your body is exposed to so that you reduce the amount of eye strain and fatigue that you get from lighting. What are some of the implications of flicker on health? So flicker can induce seizures, contribute to headaches and migraines, everything from damaging autistic children's learning ability to stroboscopic effects that can become very dangerous with moving machinery in factories. You really want to reduce flicker, and we had mostly eliminated flicker in fluorescent lighting back in the mid-60s and 70s with the introduction of electronic ballasts as opposed to magnetic ballasts. And then we sort of forgot about it when we got into LEDs. So low-quality LEDs are far more susceptible to flicker, and you really have to be careful about that. Energy Focus actually is the only UL-verified flicker-free for less than 0.1% flicker, or 1% flicker. You can't measure much below that. So that's one of our sort of real key talking points for us. So now we're going to switch over to color temperatures. So when we're talking about color temperatures, we're talking about the Kelvin temperature scale. So if you think back to chemistry, a black body heat signature is basically the heat that the color that a metal object appears at a certain temperature. So if you heat a metal object to 2,000 Kelvin, you're going to get that nice red hue to it. If you heat it up to 7,000 Kelvin, you're getting that dark blue. The warmer color temperatures are more commonly associated with calming, relaxing feelings, while the cooler color temperatures are more associated with more energizing feelings. The cooler color temperatures are also linked to increased productivity, which is very important for schools, and one of the key benefits of platforms like our nFocus platform that enable you to change the color temperatures throughout the day. So when we're talking about color temperatures in the natural setting, you're talking about the rising and setting of the sun. So warmer color temperatures at the beginning and end of the day, thinking sunrise and sunset, and cooler color temperatures in the middle of the day. So your change there is roughly from really in the low, like 1900 Kelvin in the morning, and it can get up to 25,000 Kelvin in the middle of the day. So when you think of the lights in your house, you might have daylight LEDs that you think are just far too blue. That's right around 6,500 Kelvin. It's nowhere near what the actual blue of the sky is, which is super interesting from a physiological perspective, because there's a lot of theories suggesting which parts of the day-night cycle are really entraining the circadian system, but we are fairly certain that replicating the daily color temperature cycle is certainly effective. So switching over a little bit to the hormones and the circadian rhythm, we're mostly talking about cortisol and melatonin here. So melatonin is a circadian rhythm regulator. It regulates the sleep and wake cycles primarily, but every single cell and organ in your body is affected by melatonin. It really helps keep our circadian rhythm in sync. Cortisol is what's more commonly thought of as the fight or flight hormone. It's affecting your mood, motivation, fear, your alertness level. And you want that to be in an inverse relationship and fairly regular throughout the day and fairly regular each day in a week. So how does that actually affect your health? So melatonin is a key indicator of our health for sleep. It really tells our body when it's time to go to sleep. And 2/3 of adults fail to attain the recommended 8 hours of nightly sleep. Now, a lot of us sort of think that that's not a big deal, but it really is. There are a number of diseases that, from Alzheimer's disease to just simple weight gain, that are linked to sleep. And there are a fair few studies that have shown that individuals obtaining less than 7 hours sleep have an almost 3-fold increased likelihood of becoming infected with the rhinovirus, which is what we think of as the common cold, when we compare that relative to those people who get 8 hours of sleep or more. So in times like we're in right now during the pandemic, sleep is even more key than ever. So make sure you get enough sleep, and your lighting can definitely impact that. It can also impact your memory, and sleep is critical to locking in memories from the hippocampus, so thinking your short-term storage and locking that into longer-term storage. So pulling all-nighters at school, college, probably not a great idea, but by improving your light levels, you can improve your circadian rhythm, and from that you can improve your melatonin and cortisol cycles, which is improving your sleep. So we're not saying light is going to solve everything, but if you can solve sleep, you're solving pretty much everything that you really need to think about on a day-to-day basis. And improving health is a big benefit to that. So now we're going to switch over a little bit into how to actually obtain these benefits from circadian lighting or just human-centric lighting in general. They're not that different, and they're fairly easy to control. So the first key is timing. So you really want to avoid bright and blue light in the evening. Those sort of the night settings on your phones and computers can be helpful, but just don't keep it at super bright levels. Brightness is really key to in training your circadian rhythm, and you can sort of think of those color temperature changes as being more of a fine-tuning mechanism for how you're actually going to train your circadian rhythm. So color temperatures are fantastic for evoking different feelings and increasing productivity, but it's not as great when it comes to making large changes in your circadian system. But what's really cool about that is that means that you can change your color temperature during the day, and the light will appear brighter at different color temperatures. So thinking right around 5,000 to 5,500 Kelvin is where you're maximizing the visual function, which is basically V lambda is what we're talking about here. It's the luminosity function. And so you can decrease your energy consumption and basically reduce the wattage going to a light, which is technically reducing the total light output, but your eye won't see that. It will appear to be the same as any other situation. So now I'm going to turn it over to James for a little bit more on the energy benefits of these systems and what real-life benefits you can expect from those systems.
Thanks, Chris. Obviously, as I mentioned earlier in the webinar, that the world is moving towards human-centric lighting, and it is going to bring a lot more impacts than what we have seen in lighting in the past 120 years, where lighting is just a source to give out light so we can conduct activities or having more efficient light. The good way to quantify the impact of human-centric lighting is this very simple rule of thumb from JLL. It's one of the largest real estate investment management company, property management company in the industry. And you can see that the 330 and 300 rules, where it says that in North America, every year, facilities cost about $3 in energy. That's all the energy per square foot. $30 in rent. That's, again, $30 per square foot. That's an average in North America commercial properties. And about $300 in human cost. That's personnel cost. Right. So in the past, lighting has been only, when it comes to LED lighting, it has been impacting 20%. That's about 20% of facility is energy. Again, it depends on the facilities, the type of facilities, but generally about 20% of the facility's energy cost is from lighting. So that's only 60 cents. If you look at that $3, 20% of that is only 60 cents. while human-centric lighting is really impacting human performances, and that as Chris's layout, it's physiological, it's biological, it's emotional, and that $300 could be a huge productivity source to improvement based on human-centric lighting. There have been studies that Chris has shown also in the previous slides that productivity could improve 20-30%. Academic learning performances could improve 20-30%. And if you use just 20% of that $300, that's $60, right? That $60 is 20 times of all the energy spending in the organization. And what about safety, right? I mean, as you know, this whole year, the whole world was hit by the pandemic, and the value of safety is far greater than any of these numbers. And that's where, for example, UV could really help keep the facilities safe and sanitary, again, through lighting innovations. And those are the type of field that we are impacting with human-centric lighting. And as Chris has laid out about circadian lighting, the impact of circadian lighting, we have launched earlier this year our InFocus lighting control system, and that lighting control system is very simple with just the switch and the lamps for you to introduce lighting controls to your facilities. And in the past, you have to actually deal with multiple parties. You have to deal with lighting companies, you have to deal with control companies, and you have to deal with system integrators to introduce circadian lighting to your facilities. With the advent of InFocus, you can just change the switch and the lamps, replacing the fluorescent lamps or LED tubes to get to human-centric lighting, to get to circadian lighting. That's the beauty about InFocus, making it very easy for you to start introducing circadian lighting to your facility. And the benefits that you are seeing from InFocus will be pretty wide-ranging. First of all, because it's done through power lines, so it's the safest way to communicate, so you don't need to get any wireless network into the system to do control lighting. And so that's the safest way to communicate for a lot of mission-critical facilities, such as hospitals, government facilities, military facilities, and universities. They are very sensitive to cybersecurity threats, and that's the most safest way to communicate. The second thing is that it's very simple to install because there's no networking requirement. You don't have to pull another cable through the wall. Just replace the switch and the lamps. And the third thing is that our unique and patented technology also ensure high power factor and low THD to make sure that your electrical circuits are not disturbed due to the lighting control functions. And the fourth benefit is that the cost is overall is about a third to a sixth to any lighting control systems out there, because again, the product cost is much lower and there's very little labor cost involved in introducing the lighting control function. And the fifth benefit, which is very important, as we always want to be the sustainable lighting leader, is that because you don't need to replace the whole fixture, and the lamps can be upgraded in the future as they evolve. They are the most sustainable lighting control platform. So with that platform, we were able to introduce more technology on top of that platform going forward with this lighting control technology. And the next, I want to talk a little bit about UV lighting, and that's because, as we all know, that's probably on the top of most facility managers' mind today, which is safety. And ever since the COVID-19 hitting the world in the beginning of the year, we, as a lighting innovator, we immediately started to research and develop using UV technologies to help facilities disinfect the spaces, because we know lighting, and we are a company that want to introduce innovative solutions for problems, to solve the problems. And so we basically start by developing these products by researching and knowing really what customers and facilities need. And we try to develop and design these products to be as impactful and affordable and deployable as possible, compared with all the products out there in the market today. And we have the benefit of developing these products with the latest technologies. As you probably are aware, a lot of the UV disinfection technologies were developed in the past, and that market was a very niche market. Right now, so they tend to be more clunkier and more expensive, harder to deploy. So we are able to develop these technologies with our understanding on lighting, and we form alliances with other technology and supply chain partners to integrate the latest technology to develop these products. And I'll talk a little bit more about the products that we introduced today, but first of all, I'd like Chris to talk a little bit about what UV technologies is about.
Fantastic, James. Thanks so much for that. So I'm going to do a little bit of an introduction to UV and primarily UV-C. Because the UV spectrum is such a wide portion of the spectrum, looking at 400 nanometers down to really 10 nanometers, it has a wide variety of impacts. So when you're actually classifying UV wavelength, or really any portion of the electromagnetic spectrum, you're classifying it based on how that light or energy interacts with matter, typically in terms of chemical reactions. So when you're looking at long-wave UV, so UVA, you're mostly looking at the UV that comes through the atmosphere. So the ozone layer is only blocking about 50% of UVA, while it's blocking about 90% of UVB. UVB is largely determined, how much comes through naturally, largely determined based by the weather, the latitude around, that you're in, and the season, which is primarily why you get a sunburn in the tropics while you wouldn't up in New Hampshire. So UVB is also critical for your body's production of vitamin D. So that's one of the reasons it's a super interesting little area of the spectrum. UVC is what we're focused on because it's the germicidal range. So from 200 to 280 is accepted germicidal range for ultraviolet light. 265 is actually the peak for germicidal disinfection, and that's based on CDC research. UVC has actually been around really since the early 1930s. It was developed to prevent the spread of measles in suburban Philadelphia schools by Wells. And that's really what we're focused on because it's very well proven. There's a lot of studies backing it up, and it's the accepted germicidal range. The reason I say accepted germicidal range is because you've probably heard a fair bit about the 207 to 222 nanometer range, also known as far UVC. What's interesting from a physics standpoint is the theory there is that the high energy far UVC wavelengths do not penetrate deep enough into human skin or eyes to prevent any damage. Well, that definitely shows a lot of promise for UVC applications with people in the room, other than obviously air disinfection where the UVC is contained in a unit. No long-term studies have been conducted on humans, which is why the International UV or Ultraviolet Association has recommended holding off on that until more applications, until more studies are conducted. So now that we're talking about the far UVC range and UVC range and germicidal disinfection, how do you actually determine how effective that disinfection is? So the first thing you have to do is determine what you're trying to eliminate. So currently we're trying to eliminate SARS-CoV-2, so the coronavirus that causes COVID-19. And a recent study in the past 4 months came out with the dose that's required to inactivate the coronavirus. And when we're talking about UV, we're talking about inactivation. mainly because a virus isn't alive. Bacteria is, but it's so much clearer to just refer to it as all inactivation because you're basically preventing the replication of the pathogen. That's what you're really concerned about. So when you're talking about dose, you're talking about the intensity, the output wattage, so either 254, 222, depending on what the application is. 254 is the standard for mercury discharge lamps. And you take that and you combine it with the particular wavelength, so the action spectrum of the virus or pathogen that you're trying to eliminate, the distance that it's from the target area, and the exposure time, typically in seconds. And you can then take that and compare it against lab studies where they already did the work for us. To be very precise, they're actually testing it against CFUs, so colony-forming units of a target microbe. And from that, you're able to determine what dose is required to get what percentage reduction. And so a 99% reduction would be considered a 2 log reduction, and that reduces the number of colony-forming units in a target area by 10,000. And then you really, the sort of standard that we're seeing is 99.9%, which for SARS-CoV-2 would require 3.7 millijoules per centimeter squared. That is our baseline. We cover quite a bit more than that. But then when you want to get into a greater log reduction, you just have to increase the dose. And then from that, you can determine exactly how much you're reducing the pathogen by. So it's a fairly interesting system, but it's very well studied, so it's fairly safe and standard for pretty much any product out there. Just make sure that you know what target virus or pathogen you're going after. And then once you have that, you can do the calculations fairly straightforward.
Thank you, Chris. So I'll just take the next few minutes to go through our 3 main products that we just introduced today. Overall, we believe that the awareness of pandemic and the infectious diseases is going to stay, and even if the COVID-19 subsided in the next months to come. And I think the key is how do we provide complementary and effective solutions to help facilities stay clean and safe against infections today and also into the future. And so all our products, as Chris has explained, the UV-C spectrum has proven to be the only spectrum that has been very effective in inactivating viruses, including coronaviruses. So our designs are all based on UV-C solutions, and our design not only can introduce UV-C's disinfection power, but also to keep them safe in operations. So the first product I'd like to talk about is our Nuvo. Nuvo is a air disinfection room device. It's like we call it air disinfection tower. And this is a very simple device where you can move around rooms. This goes to every room, basically. It tend to be smaller rooms. We designed this device in looking at all the markets all the products out there for disinfection, and we have found that most of them focus on air purifications, where we want to have a device that focuses on disinfection because that's what most on people's minds. Most of the purifiers focus on people that have allergy concerns, asthma, breathing problems. This device is focusing totally on disinfecting the space against virus. And so we designed it to be very powerful. It can do 4 air changes per hour in a 200 square feet space. So this is perfect for example, classrooms, meeting rooms, offices, dental offices, medical offices, a lot of spaces that are more enclosed and smaller. And the benefit of it is also that you don't have to change the filter. Because that's not our focus. Our focus on disinfecting, and we make sure that the bacteria, molds, fungi, and most viruses are destroyed through the system, and it circulates the air powerful enough. And the next product that I'd like to talk about is our abUV product. This is also a very powerful product and especially important for facilities, commercial facilities, because this product is built upon InFocus lighting control platform. You can actually replace the existing 2x2, 2x4 LED or fluorescent fixtures with the troffer and the switch to get controlled integrated troffer with both circadian lighting and UV-C disinfection. And we have built this again to be powerful, so it can do 2 air changes per hour per 100 square foot space in the 2x4 with the 2x4 and the 65 square foot for 2x2. That's sort of the average space that 2x2 covers, and 2x4 covers about 100 square foot. So we can do 2 air changes. Again, there's a built-in fan that draws the air through the system. And again, you can also visit our website, uvcd.energyfocus.com, to see the videos that show you the animation, how the air is drawn through the system. And I think it's also important to know that with this troffer, the competing product in the market today costs several times of our cost. Again, we have the benefit of leveraging on the InFocus platform to provide that capability and the latest technologies. So we're very, very excited about this product being in hospitals, schools, universities, commercial offices. This would be perfect, lighting product. As you know, fluorescent and LED troffers covers about 70% of the spaces out there. With this product, you can not only introduce UV disinfection, but also having, in the meantime, a highest quality LED lighting, which is flicker-free, dimmable, and color tunable, totally circadian lighting ready product. And the last product I want to introduce is actually a surface disinfection robot. We are very excited about this product as well, because the previous 2 products focus on air disinfection, and we know facilities are also concerned about surface disinfection. If you look at all the studies out there, the viruses could stay on surfaces for days. There was the latest research that shows that it could even stay on for 28 days. And I'm sure you can find a lot of studies around these findings. And so being able to disinfect spaces are very important for public spaces. And this is why we developed this robot, which, again, like any product we develop, we look at what the market has, and we believe that this product is a lot more affordable and also powerful. It could move at the speed of 18 inches per second for 99.99% disinfection within 1 meter, which is about 3.3. But even at 2 meters, which is 6.6 foot, it still can disinfect more than 99% of the viruses. So with a 1 meter range, you can sweep 10,000 square feet of space within an hour. There's also built-in UV lamp on the bottom, on the base of the robot, so you are also cleaning the floor. And again, and if you just want to clean the floor, for example, the robot could move a lot faster because it's very close to the surface. So it could move a lot faster for the same effect. And if you don't need to, you are focusing on the speed, you can actually move faster to get to, say, 99% and 99.9% instead of 99.99%. And you can clean a lot more spaces. This is a lot faster than any robot out there in the market. So we're very excited about this product as well. And all these products we just introduced today, and we're happy to answer any questions you have. And again, just to conclude, we are very, very excited about the age of human-centric lighting. We have positioned ourselves as a leader in human-centric lighting that would provide much better safety and biological performance for the occupants.
Okay. Okay. Thank you, James.
Thank you very much.
Thank you, Chris. Great job, guys. I just want to remind the audience that you can ask questions at any time. So please don't be shy. Go ahead and type those in. In the meantime, I do see a couple of questions have already queued up, so we will get right to those. The first question is, how is the InFocus platform sustainable?
So I think I'll take that one, Michael. So first of all, our InFocus platform is based on our tube system, so tubular LEDs, so TLEDs, which allows you to maintain the fixture, upgrade the fixture, and basically use the fixture for the lifetime of that fixture as opposed to the lifetime of the lights within it. So modular lighting systems allow us to replace a single lamp if it fails or if you want to upgrade it, as opposed to replacing the entire fixture that many luminaires today, like integrated fixtures as we call them, would require. And we've tested some of the products that are out there today, and we found that, roughly speaking, replacing a single energy focus lamp versus replacing an entire luminaire, the comparable luminaire, it results in about an 86% reduction in carbon dioxide equivalent emissions. So it's a pretty significant reduction.
Great. Okay, another one. How does GUV work to inactivate a virus? How do we know it works? And in particular, for viruses such as SARS-CoV-2.
Awesome. So I'll take the beginning of that one at least. So GUV would be germicidal ultraviolet. So basically just germicidal disinfection. It's a fairly straightforward process. Effectively what's going on is the ultraviolet light has a much higher energy than standard, even other UV-C has a higher energy concentration than other natural UV sources, and far higher concentration than visible light. And so effectively what's happening is that energy is being absorbed by a viral particle or any microorganism's DNA, and it's basically just deforming the DNA or RNA so that it can't reproduce. And these are fairly well studied, and to get those exact dose calculations, what's called UV dose inactivation. You can look it up online. There's tons of charts out there based on fairly comprehensive research studies. And so when you're looking at a product today, particularly what's out there now, you're looking at a lot of mercury discharge lamps, which are actually more efficient than the LEDs that are out there. So an LED UV or UV LED, depending on how you want to look at that, has a roughly 5% efficiency for output of UV, whereas a mercury discharge lamp is about 30% efficient. So if you're taking, as an example, say 85, 86 watt output or electrical input, you can then assume about a roughly 35 watt output. Doing the 254 nanometers is what we have a lot of numbers on for dose inactivation of SARS-CoV-2. For air disinfection, you're basically calculating fan speed, so assuming how long those particles are going to spend in the UV chamber. So you can fairly, for like our Nuvo product, you're assuming between 0.09 seconds and 0.18 seconds, depending on the speed of the fan. And then you're just taking that dose calculation and putting it into the chart to see what your dose inactivation is. It's a very robust system, and they're very well proven in lab situations.
Good stuff, Chris. Thank you. The third question is, how would you design a typical 40 by 30 by 10 classroom with energy-focused UV-C products?
That's a good question. That's a general. I would say that it applies to any space where you have 2 by 2, 2 by 4 fixtures or trophers. As I mentioned, we have designed our 2 by 4 by covering on an average about 100 square foot, which is usually how much the space 2 by 4 covers. And then for 2 by 2, it will be 65 square feet. And in that, so we encourage all the facility to replace all their fixtures with our troffer. that can disinfect the space very effectively by having 2 air changes per hour. That would disinfect 99.9% of the air going through the system. So that's a general rule of thumb to have the most effective way to disinfect the space. You will replace all the trougher with the above trougher, and again, you get not only the very effective UV-C air disinfection capability, but also that you can, in the meantime, introduce the highest quality of LED lighting.
Okay, good stuff. Thank you, James. I see a very quick question I want to make clear to everybody about whether or not we will be sharing this presentation. The answer is absolutely yes. It will be available on our website at energyfocus.com in the events section. We will also make it available on our shareholder relations website as well. You should be able to find that pretty easily. All right, let's keep going with these great questions. Number 4, or number 5, I guess, is how does Energy Focus UV-C products price point compare to your competitors?
Another great question. I think, as I mentioned, we designed these products to be as affordable as possible because we want them to be used massively. If you look at the COVID-19, before COVID-19, UV disinfection has been a very, very niche market in the world. I think the latest market research shows that even last year, the whole world UV disinfection is only about $1 billion. So that has been a very niche market focusing on mostly hospital emergency rooms, operating rooms, mission critical, basically clean rooms. While today we are talking about bringing the same capability to classrooms, to offices, right, to any kind of commercial industrial facilities. So we have to make them affordable, and that has been the guideline. As I talk about triple bottom line, the one thing very important is the financial impact, because if you're not affordable, then it cannot be deployed massively. So with that in mind, you look at all the 3 products, and they are actually product categories because we're going to have more products in these categories. All of them are comparatively more affordable, and I would say that even more powerful than the competing products. And I would say that, for example, I think our above products is priced at $395 for the 2x2 and $495 for the 2x4 retail price. That's a fraction of a similar product out there, which costs usually between $1,500 to $2,500, while we have much better control system and much more advanced control capability and the highest form of lighting, as we talk about flicker-free and circadian lighting. So again, it's the disinfection power of 2 air changes per lighting fixture. That's pretty powerful out there. So, and you look at the robot, for example, it's the same thing. The competing robots are probably selling at $100,000 to $150,000, and our price is at $39,500. We could have priced that a lot higher, but our goal is to make them everywhere, right? If a facility could have a robot that can clean their spaces, again, every hour you can clean 10,000 square feet. You can even go higher if you ask 99% and 99.9% instead of 99.99%. We're trying to be conservative. Then I think you are keeping the space a lot safer. And don't forget that the pandemics, everybody's worried about, is concerned about coronavirus. Influenza, tuberculosis, all these infectious diseases can also be destroyed by these equipment. And I think we are not only reducing the risk of infection on coronavirus, we're also reducing the flu symptoms and everything. It will keep the facilities generally safer and healthier going forward. And the key is how do we make that affordable to all the facilities? And that has been our design guideline. And I believe all these products deliver that. The last thing is about Nuvo. Even Nuvo, priced at $395, it's with competing product with the same power or similar power, is costing twice of that in the market. So I believe that these products are going to make real impact on facility safety and they could be much more affordable than anything out there today.
Thank you, James. Very good. Okay, I see one more question, and we have time. So if there are any more, please jump in. This last question for now is, who is adopting human-centric lighting, or HCL, first in terms of end users?
Yeah, I can grab that one. So really the first users are the people where it's most critical. So anywhere that you sleep, it should be your primary concern, because when you're talking about timing of lighting, what you have during the day is important. Office spaces are important, but definitely less so than where you spend your evenings or mornings. If you are spending late nights at the office, then definitely get it for your office. But we're seeing long-term care facilities having high interest, K through 12 schools being able to calm the kids down by adjusting color temperature without adjusting their circadian rhythm is very powerful. Universities are also very sort of important for that. You have students in classrooms at late hours. Dorm rooms are sort of lagging behind, but they'll probably be next. Hospitals are also super critical. Even just dimming in a hospital space can really benefit the occupants and hopefully speed recovery time. Haven't seen too many studies done on that. We'd like to do some with that, but that's for the future.
Okay, thank you, Chris. Okay, well that about wraps it up. I want to thank you all for attending today. We appreciate your time. We are so thrilled and excited to be introducing our UV line of products. And if you'd like to learn more, I would invite all of you to go visit us at UVCD.energyfocus.com, and you'll be able to really dive in and understand everything there is to know about our new product line. And we look forward to serving you. Thank you so much. We appreciate your time today.
Thank you.
Thank you. This does conclude today's teleconference. We thank you for your participation. You may disconnect your lines at this time. Have a great day.